Okay, so 4.3, last section of the year. We're talking about sums of an infinite series. So a series that goes on forever. We're going to find the sum of that. And maybe you're thinking, there's no way we can do that. And that is true in some cases. But there are cases where we can. And when we can, we have this formula where all we need to know is the first term and the common ratio. And this is the stipulation. The ratio has to be less than 1. So that means that the sequence is getting smaller and smaller and smaller and smaller and smaller. And that's why we can find the sum. Because eventually the numbers get so small that we're just approaching one number and we can add up what it should be. So if the ratio is greater than 1, these we cannot add an infinite series and the sum does not exist. You'll see D and E in your practice. So an example of an infinite series is we have someone, they walk halfway across the room, then they walk halfway again and halfway again and halfway again and halfway again. And eventually the halfways just become so small that it's just a tiny number. That would be an infinite geometric sequence or series. So we want to find the sum of this. Here's the half, and then the half again is the quarter, and then the half again is the eighth, and it just continues on. So here's our formula. We need to know the first term, which we know is 1/2, and we need to know the ratio. So because it's a geometric series, to find the common ratio, we take the second term divided by the first term. So the second term is 1/4. The first term is 1/2. So let's calculate that. 1/4 divided by 1/2 is 1/2. So, and we can see that we're timesing by 1/2 every time between every number. So now let's use the formula. So S equals to the first term 1/2 divided by 1 minus the ratio, which is 1/2. And then it just goes in our calculator. So 1/2, and then I'm going to highlight and divide. That's how you get a fraction on the bottom. Is 1, which, if you think about our situation, that makes sense because in the end we've crossed one length of the room. We've gone across one time. So if we add up all those distances, we're at 1.